Okay, well, it gave me an option to leave the meeting. How about that? All right.
Ed, you may want to mute everybody also, since the throat clearing is getting in the way.
Andy, can you handle that for me? Muting everybody. Okay, so for tonight's topic, we have Raspberry Pi for ham radio. Jason Oleham at KM4ACK is a big fan of the Raspberry Pi, as it's an amazing open source single board computer that's being incorporated into many ham radio projects. Jason has found that the Pi size and weight makes it ideal for use in portable operations and in emergency communications. All right, Jason, you're up. Take it away.
Fantastic. Thank you, Ed. And thank you guys for having me this evening. If you could make my screen full size, make me full screen. And you just let me know when you've got that.
I have no idea how to do that.
All right, let me see here.
If you should be able to share your own screen, Jason. So just go ahead and share a screen.
Let's see.
And one thing people can do is pin Jason's screen. That's what I did, and I see his KM4ACK display quite well.
Well, there you go. So he shared his screen. That's what you wanted, right?
Yes, that'll work perfectly, because now it should go full screen for you guys.
Right.
Okay, fantastic. So I do want to talk to you guys a little bit this evening about the Raspberry Pi and how we can utilize that in ham radio for various projects and digital communications. Before we get to that, I'm going to give you a little bit of background about myself and what drove me into ham radio to begin with. So we have to go all the way back to Good Friday of 2009. This is a radar snapshot of that afternoon. Now in California, you probably don't have too many tornadoes, but every one of those red boxes on the screen was a different tornado, either ground reported or radar indicated on that particular day. The images you're looking at on the screen now were captured within 1,000 yards of my home. In fact, if you look at the bottom right picture, you'll be able to see the police car sitting there. That is the entrance to my subdivision. Everything on the, all of the damage that occurred was just to the left side of that highway. It was an EF4 tornado, and if you're unfamiliar with tornado ratings, that carried 166 to 200 mile per hour winds. We lost power and communications for 48 hours, and I was completely unprepared for an event like this. Even though I've grown up in the South and dealt with tornadoes, or at least been kind of exposed to them most of my life, I've never had one this close to my home. So I didn't want to go through an event like this again, being as unprepared as I was during this event. I started with what I knew and purchased a generator for electricity and food and water that could be prepared without electricity if need be. And it wasn't until several years later that I was introduced to this weird thing called ham radio by my brother-in-law. Roughly 5 years after that event, I finally got my first license. A couple of months later, I upgraded to general. And finally, a year after that, I had upgraded to my extra. One thing that fascinated me from the very beginning was the ability to marry a computer to a radio. I've always liked toying with computers, so this was a natural fit for me. I started with modes like PSK31, which was all the rage in 2014, and dabbled in Winlink enough to understand the very basics of it. Fast forward to 2017, and I played with FT8 for a little while. And then, I don't know, a year later, JS8 Call hit the scene. Now, I was doing all of this at the time in 2014 with a Windows computer. And I stumbled across this little single board device called a Raspberry Pi. And I started playing with it for a little bit and kind of became frustrated with it in the very beginning. But the more I dove into ham radio and the more I knew I wanted to work portable operations or emergency communications, which limited me typically to battery and solar power, I started looking at how the Raspberry Pi could fit into my ham radio activities because of not only the low cost of the device, but the main thing for me was the low power consumption. A typical laptop will draw somewhere between 2 and 3 amps and usually requires 15 to 18, maybe even 19 volts. The Raspberry Pi, on the other hand, only consumes roughly 350 milliamps from a 12-volt source. So it was absolutely perfect when you needed to run from battery or solar. And there's a lot of applications that are available for the Raspberry Pi. Almost everything you can do with a Windows computer, I can do with a Raspberry Pi. The vast majority of the software is open source. Now, a lot of people, when you say open source, they just automatically think free software. And that's one advantage of open source software most of the time. But the bigger advantage is usually you can take that open source software, and if you've got the skill set, you may modify it to do something completely different. And I'll give you an example of that in just a few minutes. And finally, there's Build-A-Pi, which is a script that I've written, but we'll get back to that in just a minute. So what can we do with a Raspberry Pi? Well, Winlink is one of the primary uses that I have for the Raspberry Pi. And RMS Express that's available on Windows is not available on Linux. However, we do have a client called Pat Winlink. Some of the things we can do with Winlink is, in case you're unfamiliar with it, we can send email to other Winlink accounts. We can send email to regular internet email accounts, such as Gmail or Hotmail or Yahoo. We can send text messages. Yep, that's right. I can compose a Winlink message and send it to your mobile device. Once you get that text message on your cell phone, you reply and it will come back in to my Winlink inbox. We can also send and receive position reports. As of the latest version of PAT, we also have access to all of the Winlink forms. And we can do all of this over RF using the Raspberry Pi. Some of you may be familiar with FLDIGI. It's another great application that's got a whole host of digital modes built into it. Some of the more familiar ones are PSK31 and RIDI, but there's probably 25 different, maybe 30 different modes that you can work with inside of FLDIGI, again, available on the Raspberry Pi. In addition to FLDIGI, we've got access to the entire FLDIGI suite. So FLRig, FLDIGI, FLAMP, so forth. FLRig is one of the primary things we use for rig control with the Raspberry Pi. Now, if you've done any digital communications in ham radio, you're probably familiar with WSJTX, more commonly known as FT8. Once again, that is available to us on the Raspberry Pi. FT8 allows us to exchange a call, a grid, and a signal report with other operators, and is absolutely fantastic for filling up the logbook quickly. Now let's go back to open source, and I mentioned that we could take that software and build something else. Well, that's exactly what Jordan Shearer did when he created JS8 Call. He took the FT8 software that was open source, used the foundation of it to build JS8 Call. Jordan had this vision of being able to use the same weak signal capabilities of FT8, but exchange more than just the basic information. He wanted to do actual QSOs via keyboard to keyboard chat. And that's exactly what we've got with JS8 Call. We've got that same weak signal performance of FT8, but now we can have a full-blown conversation. He went a step further because JS8 Call builds its own network through a series of heartbeats and acknowledgements. And he built in some cool extra features like relays and messaging. And again, all of this is available to us on the Raspberry Pi. Now, if you're not familiar with JS8 Call, I have done several videos in the past on JS8 Call. I've got a link there on the screen that if you guys want to take a second and copy that down, that'll give you a list of several of the videos that I've done. Now, let's talk about Build-A-Pi. What exactly is Build-A-Pi? Well, Build-A-Pi is a script designed to remove the headaches of installing ham radio applications on a Raspberry Pi computer. Those that are first getting started with Linux, you can see their eyes glaze over if you mention building something from source. Build-A-Pi takes all of that away and just allows you to interact with a GUI interface. Now, how is Build-A-Pi different? Well, you may be familiar with Linux images or Raspberry Pi images that you can load onto a hard drive or an SD card. The trouble with those images, well, let me back up for a second. The way those images are born is someone out there takes and builds what they think is the perfect system, loading up all of the different pieces of software that they think you may want. Then they basically make a carbon copy of their drive and allow you to download it and load that carbon copy into your Raspberry Pi. The trouble is you have zero control over what gets installed. You have to take all of it or none of it. Build-A-Pi, on the other hand, gives you complete control. You get to pick and choose what's installed on your Raspberry Pi. Build-A-Pi is super easy to install. It is literally one command that you copy and paste into the terminal window. And it includes the most used ham software that I've already told you guys about: Winlink, WSJTX, JS8 Call, and FLDIGI. You can completely customize it to suit your needs. So if you're building something like an APRS digipeater or an iGate, you really have no need for, say, the RDOP HF modem. So you don't have to install that. You can specifically design it or install what you need for your project. Now, I mentioned the installation is literally one line of code. This is a screenshot from the GitHub page for Build-A-Pi. In the gray box, you see what appears to be 2 lines of code. Linux, because of the backslash at the end of the first line, treats this as 1 line of code. So you simply copy that, paste it into a terminal window, and press enter. Takes it about 4 or 5 minutes to get everything going. And then this is the first screen that you're presented with. You simply enter your call sign here and press continue. You'll then be presented with the first of 4 screens for various things that we can install on the Raspberry Pi. Each of these is as easy as putting a check mark over there on the left-hand side by the pieces that you want installed. So the first screen here is kind of the foundational apps that we may use for various projects. Things like HamLib, which is used for rig control. We've got the GPS and the GPS update tools. RDOP is a modem for HF. You would use that if you were going to do, say, Winlink HF communications. Direwolf is also available. If you guys, you might remember the Cantronics TNCs from years ago. Well, we no longer need those terminal node controllers. Direwolf is a software solution that can replace that. So that can eliminate one piece of hardware that you're trying to integrate into your system. The second screen that you would see if you were doing a Build-A-Pi install is the FLDIGI suite. Again, especially if you're new to this, you don't quite understand it, I would definitely recommend, if you want to do any rig control, make sure you get HamLib on the first screen and FLRig on the second screen here. The third screen you're presented with is more of the ham radio specific applications. So things like Pat Winlink, Pat Menu. Pat Menu is another script that I have written that can be installed with Build-A-Pi. Pat Menu allows you to interact with a lot of the settings, things you may need to turn on or off in Pat Winlink. And it goes a long ways to keep you off of the command line when you need to configure Pat. We've got applications like Chirp that'll help us program various radios. You've got WSJTX, JS8 call. The next two down the list are Exaster and Yak. Those are two different APRS clients. And you can see in the screen here, I picked Exaster on this particular build to install and didn't install Yak. Typically, you don't need two different APRS clients. Below that, we've got three different logging softwares that we can choose from. PyQso, CQR Log, and Hammers. Hammers is kind of a newcomer on the scene, and it's really geared towards Parks on the Air operators and Summits on the Air operators. It's one of it's fast becoming one of my favorite logging softwares for Parks on the Air. We can do slow scan TV. Grid Tracker is an application that the guys that utilize WSJTX, they use Grid Tracker to keep up with which grids they've worked with WSJTX. We can do propagation prediction and even Logbook of the World software with the Raspberry Pi. And the last of the screens that you will be presented with is some utilities. Some of those are as basic as a dipole calculator.
And then when Christian repeated it when he was little, my dad was like that.
And some of those are as complex as BPQ or Lin BPQ software. With Lin BPQ, you can build a Winlink gateway, or you could build a full-blown bulletin board service, or you can combine the two into one system. It's a really slick piece of software. Hopefully, I'm gonna be able to do some videos on that in the coming months. So with Build-A-Pi, you can build all kinds of different Raspberry Pi projects. The gateways, the digipeaters, logging software, Winlink software, slow scan TV, satellite prediction, it's all there with just a simple click of a button. Now, I want to take this full circle to where we started with the tornadoes. Christmas morning of last year, we woke up to the Nashville Christmas bombing. The image you see on the screen was taken, I believe, that afternoon or the next morning, showing some of the devastation. The bombing targeted the AT&T building, and once again, I found myself without internet and without cell phone. That outage spread well into Kentucky and as far south as Atlanta, Georgia. Fortunately, this time I didn't lose power, and I had a communications plan. Using the Raspberry Pi computer and a Yaesu 817 on 1 watt, I was able to send Winlink emails out, both as email and as SMS text messages. So I was able to let my mom know, who's not a ham radio operator. I sent her a text from Winlink to let her know, yep, you're seeing what you're seeing on the news, but we're still okay. And I was able to keep those lines of communications open until our regular services were restored. If you want to learn more about the Raspberry Pi, I do have a YouTube channel. I do a lot of videos around the Raspberry Pi. Also encourage you to visit the Raspberry Pi Foundation's website at raspberrypi.org. And we can take questions. If you'll give me just a second, I'll try to get my screen shrink back down and get my camera fired back up here.
All right, very good. Thank you, Jason. Are there any questions?
Jason, do you
yeah.
have a recommended set of hardware to put together the Raspberry Pi that will support this stuff?
Most any of the Raspberry Pis will support it, at least the Raspberry Pi 3 and definitely the Raspberry Pi 4. If I was going out right now to purchase one of the particular Raspberry Pis, I would look at a Raspberry Pi 4 gig model and put with that a 32 gig micro SD card, and you should be set.
So you don't need anything to stack on top of it then?
Now that depends. It depends on what you want to do for your particular situation. If you're looking to carry it into the field and run it off of a 12-volt battery, you may want to get something like the Maker Focus power board that will do the conversion from 12 volts to 5 volts, which is what the Raspberry Pi needs in the field. If you want GPS, you're going to have to add GPS to it. That may be an external GPS dongle. If you're running something like the ICOM 705 that's got built-in GPS, you can actually pull that data from the 705 into the Raspberry Pi. So it's all very specific to your particular situation.
Thanks.
I believe Phil had a question.
Well, I was just going to express the fact that I feel like I'm here at a beginner's level and need to know how to start and how to move into utilizing the Pi more thoroughly through my system. And I guess I would look to your website, but are there any other tools for the beginner wanting to pick up the Pi and make something out of it?
So the first thing you're going to need to do after you purchase your Pi and your micro SD card is you're going to need to download the operating system from the Raspberry Pi Foundation's website and get that loaded onto the micro SD card. There's a lot of videos out there on YouTube that'll walk you through that step by step.
Okay,
Once you've got the OS loaded, you can go to my GitHub page. That's github.com/KM4ACK. You scroll down to the install section and literally copy and paste that one line of code into your terminal window and press return. Once you do, you're going to be presented with the same screens that you saw here in the presentation this evening. Then depending on what you want to do, you can load all of it. If you're brand new to it, you might want to load it all just to kind of become more familiar with some of the different applications. If you have a specific project in mind, you may only want to load bits and pieces of it. I also maintain a forum. So guys that are brand new to it, if they get stumped somewhere, they can go over to the forum and post a question there. That's a groups.io forum. And again, if you just search my call sign, you'll find our group. And on the forum, you are moderated for the first post. After that, we unmoderate you, and you'll find a lot of great guys over there willing to help out.
Thank you, thank you.
Very good. And Joe had a question.
Yeah, I am really new to all this, and my other question is, what's the primary interface to the radio?
Again, that's very specific to which radio you're using. With something like the Yaesu 857D, it takes a $7 sound card and a couple of cables, probably $30 worth of interfacing there. You can always use the Signal Link. That's one of the pricier options out there, but it's probably the simplest to get going. If you've got something like a ICOM 7300 or the ICOM 705, they have the sound card built in. You can literally take the cable out of the box with a radio and plug it right into the Pi, and you're ready to go. A little configuration is going to be required, but no other interface is required between the Pi and the radio.
Thank you. I have an ICOM, so that's.
Which particular ICOM?
A 7700.
I'm sorry, I didn't catch that.
That's a 7700.
Okay,
ICOM.
I'm not familiar with the 7700. I know the 71, the 73, and the 705 all have a built-in sound card. You'd have to check in the manual and see if that one has a built-in sound card or not.
Okay.
Okay, any other questions?
Yes, this is Ryan. I was wondering if you've done any work with the RTL SDRs or the hack RFs?
No, I haven't. And that's not something you're going to find yet in Build-A-Pi. However, after you're done loading Build-A-Pi, you could always add that software on top of Build-A-Pi. Nothing's preventing you from loading additional software to it. I do recommend if you're going to run Build-A-Pi, don't run it on a system that you've already started playing with. I would run it on a clean build of the Pi OS, and then add additional things to it after you've got Build-A-Pi installed.
Okay, thank you.
You're welcome.
Great, thank you, Ryan. Greg.
Yeah, Jason, I think I'm kind of back to what Phil was asking, that whether it's on your website or not, but you had a whole bunch of applications on there. And for somebody who's just beginning in order to get their feet wet, what would be the applications that you would recommend, regardless of what somebody had for a radio, so that they could be familiar with what application is doing? And it's kind of like, how many applications can you load on the Pi and get on the window of your display, and then switching from one application to the other? You can kind of get overloaded with too much information. So if somebody wanted to do Pi just for Winlink portability, or for a home base emergency station, would your website show a representative configuration and how to go about that?
So on the GitHub site, if you scroll down to the bottom of the page, there is a description of most of the software, not all of it, because we've been adding some things over the last few months and I haven't gotten that section updated. But that would give you a description of a lot of the applications that are available and when you might want to use those. The other thing I would recommend is, again, the forum, because if you said you just wanted a Winlink station, a client Winlink station, The next thing I'm going to ask you is, do you want just HF, or do you want just 2 meters, or do you want a combination of both? Because depending on how you answer that is going to be what I'm going to tell you to choose from the menu system to be installed.
Okay, now, are you familiar? I can't remember the guy's call sign, but he has the Nexus, the Raspberry Pi, the switching IO board that you can use to put 2 radios running simultaneously.
Are you talking about the Draws hat?
Next, let me go get the little box.
Okay.
Yeah, because the Draws hat you can run, it has 2 cat cables, 2 cat ports.
Correct, but the Draws hat has their own custom image with their own software that they run. I've never tried to load Build-A-Pi onto the Draws hat image to see what happened. I think Victor had a question while we're waiting on him to get back.
Okay.
Hey, Jason, question. So I have a little bit of experience with using a Raspberry Pi. So I prefer it to be headless, means that without a screen, say for running a D-Star hotspot. So is the Build-A-Pi design a way that it can run headless, or it always should come with a screen? And what's your solution to get a screen in the field, say, for example?
So absolutely, great question, and a man after my own heart. I do not have a monitor plugged up to a single Raspberry Pi that I own, and I think I'm up to 11 or 12 of them now. So you can absolutely run it headless. And I kind of skipped this intentionally during the presentation. There's 2 applications in there. One of them is called Hotspot, and the other one's called Hotspot Tools. And it's not to be confused with something like the DMR hotspot. That hotspot creates its own wireless network when it's running, so that you can connect to it in the field. So you can connect to it, you fire the Raspberry Pi up, it'll create that network, and then you can use any other wireless device, your cell phone, a tablet, or another laptop to connect to it, VNC into the Raspberry Pi, and then you've got full control over the Raspberry Pi in a familiar desktop environment.
Okay, Jason, I got here it's WB7 Foxtrot Hotel Charlie. He's got what's called a Nexus, just the DR-X, and it gets built on top of a Raspberry Pi 3B or 4. On the bottom rack, I got 4. So we got 2 Raspberry Pis. The intention here is his stack to go ahead and put in the 2 radios to run simultaneously and switch between one or the other. So you would be able to show on the screen whatever application you were running if you want to have a monitor on that.
Okay, I'm sorry, I'm just not familiar with that piece of hardware.
Yeah, it'd be interesting if your applications would load in, because can you not load more than one operating system on the Pi by partitioning them?
Yes, I'm sure if you partition them off, you could probably load multiple operating systems onto the same SD card.
Okay, because there's plenty of room on a 32 gig.
Yes.
All right, very good. Thank you, Greg. Any other questions? I'm not seeing anybody. All right, well, thank you, Jason. I appreciate it. And I'm sure we'll all go check out your GitHub and your YouTube page.
Absolutely. Thank you guys for having me this evening.
All right, thank you very much. Appreciate it.
Yes, sir. 7-3.
All right, 7-3. Good night.